Hello, welcome back to Cinderella Math. Today I'll be doing a video on factoring trinomials. And my favorite method is using the magic X method. There are several different ways to do this. So if your teacher or tutor or parent or whoever has taught you a different way, that is fine. But this video, I'll be particularly going over the magic X method. It is my favorite. Um, Not necessarily the best, but I think it's the easiest to do. Alrighty, so we're going to go ahead and get started. All right. So first of all, a trinomial. You probably already know what this means if you're on this video. Oh, by the way, this is about probably an Algebra 1 level if you're just learning how to factor. If you're in Algebra 2, this is a great review and something you'll certainly need in Algebra 2 or pre-calculus. If you're getting ready for the SAT or ACT, this is definitely on there. So no matter really what level of high school math you're in, you can benefit from having this skill. It is a super important skill for all of high school. So trinomial, you can see that root word, root prefix there, tri. That means three, right? Like a tricycle, three wheels. All right. So these do need three parts for this to work. And I'm going to start, so trinomial, the standard form is ax squared plus bx plus c. And of course, this is called a quadratic. This method will work for other things other than quadratics, but this is most used for quadratics. And I'm going to start my first several examples. This a value will be equal to 1. And then after a few of those, I'll do when a is not equal to 1. It's a little bit harder. So we're going to start with quadratics with a equal to 1. And here's our first example. Alrighty. I have x squared plus 7x minus 18. And again, see how there's no a value? There really is, right? It's an invisible 1, and I would recommend go ahead and put that in, especially if you're just learning this. Okay, so this is our a, this is our b, this is our c. For the magic X method, off to the side or on scratch paper or whatever, make a big X, not like huge, but bigger than like a normal X that you would write if you're like writing the word X-ray, make it bigger than that. And then you're going to do A times C. And you're not going to worry about the X's or whatever letter you're dealing with, just the numbers, the constants. So take A times C. And I will even make this big rainbow to help me out there. So let's do 1 times negative 18, and that is negative 18. Okay, so this one at the top is always A times C. And then at the bottom, you're going to put the middle number. Again, ignore the letters. So our middle number, our B value, is 7. Okay? All right, and now this is where your times tables, so all the way back to 3rd, 4th grade, this is where your times tables really come in handy. Of course, if you need to use a calculator and you're allowed to do so, feel free. I'm not your teacher, so I do whatever your teacher wants to do. I would love if you could do it without a calculator and you have really strong times tables, but if you need one, go ahead. It's fine. All right, what we want to do is we want to find magic numbers. So that's why I call this the magic X that multiply here, add here. So I'm going to get rid of this now. So magic, just remember, so this is the magic X method. And again, we are factoring quadratics. So magic, M-A. M at the top, A at the bottom. So we want to go through our times tables and think about what multiplies to 18. You can kind of ignore the negative for a second. And if you need to, even kind of come off to the side and say, okay, what multiplies to 18? 1 times 18, 2 times 9, 3 times 6. Out of those possibilities, we needed to add to 7. So if you look at those choices, 9 and 2 is probably going to get you to 7, or 2 and 9. The order you write these doesn't matter, by the way. But they need to add to 7. Well, 9 plus 2 is 11. Well, what about 9 plus -2? Right? 9 plus -2, that would be 7. And how about the multiplying? 9 times -2, yep, that would be -18. So these two numbers, these are your magic numbers. They multiply here, yes, and they add here. And again, the order could be switched. If you put the -2 on the left and the 9 on the right, it's fine. Okay? And now let's factor. So you're going to make 2 sets of parentheses. These are called your factors. Sometimes I'll call them babies. I don't know why. It's just a habit. All right. And then see this x squared? You're going to rip that in half. So 1x for me, 1x for you. And then take your magic numbers. That was a +9 and a -2. And again, they can be switched. If you did the -2, then the +9, it's fine. This is done. We have factored that green quadratic. We are not solving. I will do a separate video on that. It's just one step further. For today here on this video, we are factoring. Great. If you want to check, you would take my pink answer and you would foil it or rainbow it or multiply, whatever you call it. You would multiply it back and it will give you this result. That's how you can check. So factoring is basically unfoiling. All right, let's do another one. This does take a while to click. Okay, so if this doesn't make sense, like right now, it's okay. Give yourself some grace. It will click. It just takes a little bit sometimes. And again, I'm still going to let that a value be 1. Here is example 2. All right, I've got x squared minus 6x plus 5. And again, we want to put in this invisible 1. Make our x off to the side. You do the first times the last, just the numbers. So 1 times 5 is 5. And the middle number is -6. So again, this is A times C, and this is B. Some teachers call this the AC method. So if you hear that, they're most likely meaning this method. I call it magic X, but there you go. We want to multiply here, add here. So again, if you're strong at times tables, you probably don't need to come to the side, but you're welcome to do so. Ask yourself, what multiplies to 5? Well, 1 times 5. That's it, because it's prime, right? So 1 times 5. Okay, well that multiplies to 5, but I needed to add to -6. I like to think of it as money. If you owe me 1 plus you owe me 5, that would add up to -6, right? -1 plus -5 is -6. And then if you multiply negative times negative, -1 times -5, negative times negative turns positive. So we've done it. We have found our magic numbers. And again, those could be switched. The order does not matter. 2 parentheses to build 2 factors. Take this x squared, rip it apart. 1 for me, 1 for you, and then insert the magic numbers. -1, -5, those could be switched. Done. It's kind of fun once you get the hang of it, I promise. All right, let me see if I can find another one here. All right, here we go. Here's example 3. I'm still going to have a equal 1. I'll bump it up here in a minute. Example 3. 5x squared minus 35x plus 60. And you might say, hey, lady, you just said that a is going to equal 1. And it doesn't. This a is 5. Well, look at the whole problem, though. Look at that whole blue trinomial. We have a GCF. So when we have a greatest common factor, we need to pull that first. So go through your times tables, or really division tables. What can you divide out of 5, 35, and 60? You can divide a 5. So let's pull that out. Let's pull the GCF. What's left over? 5 divided 5 is 1 with an x squared. 35 divided 5, that would be minus 7 with an x. 60 divided 5 would be positive 12. So yay, now our A is 1. This is our A, B, C. And you're going to ignore the 5 for now. He's fine for a second. Let's make our X. A times C is 12, and our middle number is negative 7. So we need to multiply here, add here. So again, if you're strong at times tables, you probably don't need to do this step. You can just do it in your head. But feel free to come off to the side. What can give us 12 with multiply? Well, 1 times 12, 2 times 6, 3 times 4. And which one would get you 7? 3 and 4, yeah? But oh man, I need it to be negative 7. So if you owe me 3 plus you owe me 4, you would owe me 7. And if you do negative times negative, it would multiply positive. Yay, we have found it. Found our magic numbers. Back over to the problem. Drop the 5. He's just along for the ride. Build your 2 parentheses. See this x squared? Split it. 1 for you, 1 for me. Put your magic numbers. Negative 3, negative 4. Again, those could be switched. Answer. So that one was a little bit trickier because we had the GCF, but once you pulled him out, that 5, we were good to go. I will do just one more before we bump it up a notch. And this one, it's kind of unique, but you won't see from the get-go why it's unique. So here comes example 4. I've got x squared minus 16x plus 64. This is a 1, so there's no GCF. If that's a 1 in front, there is not going to be a GCF. So yay, we'll make our x, do the first number times the back number, so that'd be 64, and the middle number is negative 16. We want to multiply here, add here. Again, you can skip this step if you're good at times tables. If you need to write it down, feel free. What can give us 64 with multiplying? Well, 1 times 64, 2 times 32, 4 times 16, and 8 times 8. I think that's it. All right, but we need this to add to 16. Okay, so 8, 8. Ah, but it's negative 16. Well, owe me 8, owe me 8. Add that together, you'd owe me 16. And negative times negative results in a positive. So we found the magic numbers, yay. Build our babies, factors. See this x squared? 1 for you, 1 for me. And then a minus 8, minus 8. Now this is correct. X minus 8, x minus 8. Or we can get a little fancy with this one and say x minus 8 squared, because it's times itself, right? That is the definition of something being squared. So either one is right. I would say the bottom answer, just the x minus 8 squared, is, I mean, it saves you time because it's quicker to write. It's a little more fancy. So particularly if you're in that algebra 2 or beyond level, you probably want to do the square, even though they're both right. Doesn't really matter, but the square is just a little more fancy. All right, let's kick it up. Let's do when A is not 1. So this is harder, but just a smidge. So factoring, we're still doing quadratics. So it still has the form ax squared plus bx plus c, but this time a does not equal 1. We're still going to use magic x, but this is now a cheat magic x, and I will explain what I mean by cheat. Okay, let's get an example here. Okay, example 1 of this section here. 2x squared plus 5x minus 3. And again, I'm still factoring. I will not solve in this video. I'll do a separate video for that. All right. So you still check for a GCF, 2, 5, and 3. Anything come out? No. But we check because there still could be a GCF, but not on this one. So again, just go ahead and build your magic X to the side. And you're still going to take the first number A times the back number C. So again, this could still be called the AC method. So 2 times negative 3, that's negative 6, and the middle number is 5. And we need to multiply here, add here. So still the same setup. Again, you can skip this step if needed, but we're going to try to multiply to 6. Ignore the negative. Just think of 6 for a second. Well, 1 times 6, 2 times 3. Ah, they'll both give you 5. Okay, so we really do need to think about the signs here. All right. I think we're going to pick this one. What if you have 6 spend 1? You would still have 5, right? So 6 plus negative 1, you still have 5. But 6 times negative 1 is negative 6. Yes. It's because if you did 2 and 3, they both would have had to be positive to give you 5. Yeah. So I think we got to go this way. Okay, yay, we found the magic. Positive 6, negative 1. It multiplies here, adds here. Still build your 2 parentheses. Still look at your x squared and rip him apart. 1 for me, 1 for you. Still put in your magic numbers, which was a positive 6 and a minus 1. But if you foiled this back to try to check, it would not work. See, we need a 2 in front. X times x is just x squared. We would never get that 2x squared. Okay? So why do I call this a cheat? Is because technically when this front number is anything other than 1, when we did this multiplication right here to get this magic x going, that multiplication is technically not allowed, but we do it anyway just to get our problem going. So that multiplication is cheating. I know, we shouldn't cheat, but bear with. Okay, that multiplication is cheating. Oops. So what's the opposite of multiply? Divide. So we are now going to divide to uncheat. Okay? So it's always this front number. He's the cheater. We multiply 2 to cheat, and now where are we going to divide it? You're going to divide it under both magic numbers. Okay? And now see if they divide pretty. Well, what's 6 divide 2? That's just 3. So this one's just x plus 3. And what's 1 divide 2? I mean, that's a half or 0.5, but we don't want decimals. And, we could leave it x minus a half, but still when you FOIL it back, x times x, that's still x squared. We're still not going to get the 2. So the trick is you take, if it's a fraction, and It doesn't simplify. So does 1/2 simplify? No. You're going to take the bottom, the denominator, and swoop, that is a very technical term there, swoop that 2 to the front. So that's going to be 2x subtract 1. Answer. Those are the factors for that original polynomial. Again, if you wanted to check, you would FOIL this back and it would give you the original quadratic. Okay, I know. Again, give me a couple examples. This does not typically click for people right away, and that's okay. Give yourself a second here. Let's try this again. Trying not to get rid of my kind of title there. There we go. All right, here's example 2 of the cheat kind. I have 3x squared minus 13x minus 10. Check for a GCF. 3, 13, 10. No, nothing comes out. But it could, so that's why we always check. And now make your magic X. First times the last, negative 30. Middle number, negative 13. What can multiply to 30? Again, ignoring the sign for a second. 1 times 30, 2 times 15, 3 times 10, 6 times 5. Okay. We need it to add to 13. So this could give us 13 and this one. So we are going to have to check the signs. I need you to owe me 13 and I need it to multiply negative. So I think we'll have to do this one. What if you have 15? No. What if you owe me 15? Give me 2. Yeah, that'll work. Okay, because negative 15. So again, multiply here, add here. Negative 15, give me 2. You'd still owe me 13. So the add's right. And negative 15 times 2 is negative 30. Yeah. So sometimes the magic X takes a moment. Well, we got it. There's our magic numbers. Build your babies, your factors. X squared, split it. 1x for me, 1x for you. And our magic numbers was minus 15 and plus 2. And again, you could switch those. If you do the plus 2 first and then the minus 15, it's fine. But this front number, cheater, because it's anything other than a 1 is a cheater. So when we multiplied, we cheated. So we're going to divide the cheater. Divide 3, divide 3. And now just see if that cleans up any. 15 divide 3, well, that's just 5. So this is x minus 5. 2 divide 3, no, that doesn't go pretty. And it doesn't reduce. So we're going to take the denominator and swoop. So that's going to be 3x plus 2. And again, you can check yourself by foiling it back, and it should give you this original problem. I'm not going to do that, but you certainly could. See here. Let me see if I can find another one here. I can't really make these up in my head because they might not factor nice. So give me 1 second here. Trying to find one where it would have a fraction on it, but it would like simplify. See how 2/3 does not simplify? I want to show you one where it would. Trying to find that. Hmm. All right, I'm not sure if this one will or not. Let's try it. Let's go with this for example 3. All right, I've got 6n squared. So it can be something other than x minus 23n plus 7. Check for GCF. 6, 23, 7. No, nothing comes out of there, but we check anyway. And we build our magic x. First times last, 6 times 7 is 42. Middle number is negative 23. We need to multiply here, add here. What gives us 42? Well, 1 times 42, it's even. So 2 times 21, 3 times 14, and 6 times 7. There's all our 42s. And again, you may not need to do that step, especially if you're really good with your times tables, or you can just use calculator, whatever is best for you. All right, we need this to add 23. Okay, I think we got to go here because 21 plus 2 is 23, but oh, we need negative. So owe me 21 plus owe me 2. You owe me 21 plus you owe me 2. You'd owe me 23. And if you multiply, negative times negative is positive. Yep. Okay, great. So build your babies. And now watch out. It's n squared. So that's 1n for me, 1n for you. So again, it works the same with any letter. And now put in your magic. We had negative 21 and negative 2. Again, those could be switched. It does not matter. This front number was not a 1. Therefore, he's a cheater. This multiplication is cheating. So we have to divide to uncheat. So we're going to divide 6 under both magic numbers. And yay, this did what I wanted it to do. Now 21 divides 6, that does not go in pretty, but it does reduce. So pretend you're back in like 6th grade math for a second. Reduce that. So you can divide by 3, and that would be n minus 7 over 2. And the other one, 2, 6, that doesn't go in pretty either, but it does reduce. Divide by 2, that would be n minus a third. Okay, so if the fractions reduce, reduce them. That is key. And that's why your 6th grade math teacher or your mom, your dad, whoever taught you math, tutor, whatever, whoever taught you 6th grade, 5th grade, really hounded on reducing fractions. Super important skill. Yes, some calculators will do that. So if you want to use a calculator to reduce, by all means. Honestly, it's faster in your head, but if you want to use the calculator, go for it. And now, those are just, that is the answer. But again, if you FOIL it back, it would be n times n, which is n squared. So if we just swoop the fractions, we'll get the formal answer. So take this denominator, swoop. So that would be 2n minus 7. Whoops, sorry, my pen went nuts. And take this denominator, swoop. That would be 3n minus 1. And now if you wanted to check it, you would FOIL those two factors back together. And if you FOILed it, it would give you this. Great. All right. I mean, certainly there's more to factoring quadratics than this, but this is the meat and potatoes. If somebody came to me and said, hey, I'm taking the SAT in 3 days, this is the first thing I would do with them. I would make sure they can factor. It is that important. So to me, I've been teaching high school math for over a decade. This is probably in the top 3 skills of high school math. So watch this video over and over. There's tons of other great YouTube videos as well. Type in Magic X. If you didn't like this method, type in on YouTube factoring quadratics and you will see other methods out there. This for me personally works the best and I've had the most success with it with my students. I hope this video was helpful. I will do a second video on solving quadratics with the Magic X. So it's just one more step. If you can do this, you can solve. Okay, so this was factoring quadratics, particularly trinomials with the Magic X and the cheat Magic X. If you have any questions, please leave them below, and I hope you're having a great day. Bye-bye.